Okay, so our project was analysis of COVID-19 vaccine distribution versus income level. I'm just going to do a quick demo of the code that we have. So these are all the data sets that we used. We got them all from Kaggle. And then we started by installing PySpark and starting that Spark instance. And then I worked first with the United States vaccine data. I created the data frames from our data sets. I joined them all into one data frame, which I printed out here. And then I did some plotting to visualize the data. First, I did median income versus percent people vaccinated, and this is for each state. Next, I did median income versus share of doses used. And then I did median income versus daily vaccinations per million. Next, I tried to do K&N analysis on the US vaccination and median income data sets. However, it didn't prove useful. I think that this was because of the categorical data, or it not being categorical data. And then I did the linear regression model, and that actually ended up having a pretty good fit here. It had a low RMSE, which means the model is fitted well to the data. And then I selected the 5 top correlated features and then redid the linear regression model using just those features and was able to double the accuracy score. And it had a really low RMSE there. So that shows that that is a good indicator, the median income of vaccine rollout. Then I did global vaccine data. So I created the data frames again. This time we did a couple of different data sets for the economic standing, so like minimum wage, the PPP, we tried life expectancy and GDP. So I created all those data frames and joined them all into one, and then did some more graphing. So we had the GDP versus people vaccinated per 100, life expectancy versus people vaccinated per 100, minimum wage, which is in US dollars per hour, people vaccinated per 100. And then lastly, the purchasing power parity, the PPP, people vaccinated per 100. And so all of these, you can see that they did have a relationship. There are trends in the graph. However, it's not as strong of a linear relationship as it was for the United States data, which makes sense since there's a lot more factors going into the global vaccination rates. So then here we were able to use a categorical column. So this K&N analysis had a much higher accuracy score of 83%. And we used all of these columns here to predict the status column. So it was either developing or developed, and it was able to accurately predict that 83% of the time. So there is a strong relationship between those variables. Then we repeated the linear regression model. This one didn't do quite as well as it did for the US data, again, because it wasn't as strict of a linear relationship. So this one, the RMSE is much higher for these, which means the fit isn't as good on the data. However, it did still have a not horrible accuracy score, and then it got a lot better for some of these. So this one was it was total vaccinations. This one was on daily vaccinations per million, a little bit better. This one, total vaccinations per 100, about the same. This one had a pretty low one with daily vaccinations per million, and then GDP was used to predict that. And then this was by far the highest accuracy score for this one. It was about 55%, and this was with daily vaccinations per million and life expectancy. And that graph did have a pretty clear relationship. So that makes sense that had the highest one. So all of this analysis and using the models to predict showed that there was, in fact, a pretty clear relationship between the economic variables and features that we were looking at versus vaccination progress in the countries and just within the states in the US. However, we did find that globally there were a lot more factors that influenced the exact vaccination progress other than just the economic standing.